Hello, I'm Dr. Islam, and today we're going to study the laws of indices. And this is in GCSE Mathematics, higher level. So our learning intentions for today are to review the law of indices. So that's with multiplication, division, brackets or raising a power to another power, negative or reciprocals, and fractional indices. So before we begin, let's have a quick recap of terminology. So if we had 3 and then a little 4 up to the right hand side, we say this is 3 to the power of 4, or 3 raised to the power of 4, or 3 to the 4. The number 3 there is the base, and the number it's raised to, the 4, is called the power index or exponent. So multiplying power expressions with the same base. So say we had 3 to the power of 5 multiplied by 3 to the power of 4. How could we write this multiplication out in full? Well, the long-winded way of doing this would be to write out 3 times 3 times 3 times 3 times 3, 5 of them, and then also times by 3 times by 3 times by 3 times by 3, another 4 of them. So looking at that all together, we could write this result of this multiplication in the form of 3 to the power of something, k, like 3 to the power of k, and we realize we end up with 3 to the power of 9. So what do you notice about the powers that the 3 was raised to, and then the final power in the questions after the multiplication? Have a think about that. So we had 3 to the power of 5, we had a 5 and a 4, and then we ended up with 3 to the power of 9. So well done if you realise that when you're multiplying with the same base, in this case where the base is 3, you add the powers. So you get 5 plus 4, which is 9. So the first law of indices, write this in your book. A to the power of b times a to the power of c is equal to a to the power of b plus c. So if you've written that down very quickly, have a think about this extension question. A to the 3 times a to the 2 times a to the 4 times a to the 5 times a to the 9. Okay, pause the video if you'd like more time to work out, otherwise carry on and I'll give you the answer is a to the power of 23, because if you add them all up you get 23. So, dividing power expressions with the same base. Say we had 4 to the power of 7 divided by 4 to the power of 2. Right, remember, the written as a division can also be written as a fraction. So, how could we write this division out in full? Well, the long-winded way of doing this would be to write 4 times 4 times 4 times 4 times 4 times 4 times 4, 7 times, divided by 4 times 4. And after doing that in full, we can cancel down the dividing by 4s with the 2 from the numerator with 2 from the denominator, and we end up with how many 4s? We end up with 4 to the power of 5. So how could we write this result of this division in the form of 4 to the power of k? Well, it would be as 4 to the power of 5. Now, have a think again. We've got powers of 7 and 2, and we have division, and we ended up with the answer being 4 to the power of 5. Can you spot what the general relationship is between the powers when we have division? So this comes to our second law of indices. I'd like you to write this in your book. A to the power of b divided by a to the power of c, we get a to the power of b minus c. We subtract those powers. If you finished writing that have a think about this extension question. A to the power of 300 divided by a to the power of 23. If you need time to work it out, pause the video. Okay, so a to the power of 300 divided by a to the power of 23. We do 300 take away 23, and we end up with a to the power of 277. Let's move on to another law of indices, when we have raising a power to a power, or when we've got those brackets there. So we've got 4 squared in brackets to the power of 3. So what does this mean? Well, this means that everything inside the bracket is cubed. Inside the brackets we have 4 squared, so the whole 4 squared is cubed. So how could we write this multiplication out in full? Well, it would be 4 squared times 4 squared times 4 squared. Now, using the index laws for multiplication, we'd simply add those powers. And how could we write the result of this multiplication in the form of 4 to the power of k? Well, adding those powers up, we end up with 4 to the power of 6. Now, our answer is 4 to the power of 6. Now, have a look at the powers in this question. What is the general relationship, can you notice, about the powers when you raise a power to another power with those brackets? Okay, so has anyone spotted that 2 multiplied by 3 gives us 4 to the power of 6? So we come to our next law of indices, and write this in your book. When you have a to the power of b in brackets to raise to the power of c, we can write that as a to the power of bc. Remember, in algebra, bc, that means it's b times c when they're next to each other. So if you followed that and would like a challenge, I've got an extension question for you here. A cubed to the power of 20. Now, pause the video and have a work this out. Your answer should be a to the power of 60, because 3 times 20 is 60. Now we'll move on to negative indices. So to understand negative indices, we're going to have a look at some patterns. Remember, in maths, it's all about trying to spot patterns and relationships between things. So is there a pattern that we can see here to help us out? So 3 cubed is 27. If we divide by 3, we end up with 3 squared, which is 9. If we divide by 3 again, we end up with 3 to the power of 1, which is just 3. Now, if we divide 3 by 3, we end up with 3 to the power of 0, which is 3 divided by 3, which is 1. If we move down another row, if we divide by 3, well, we'll end up being 3 to the power of minus 1, and we have to divide that 1 by 3, and we end up with a third. What about dividing by 3 again? We end up with 3 to the power of minus 2, and that's 1/9. So there are lots of things to spot here. So going from the top to bottom, we were dividing by 3 each time. So we were going from 3 cubed to 3 squared, 3 to the power of 1, 3 to the power of 0. 3 to the power of 0 happened to be equal to 1. Then when we got to the negative indices, dividing by 3 each time, we ended up with 1 over 3, and for 3 to the power of minus 1, and 3 to the power of minus 2, we ended up with 1 over 3 squared, which is 1 over 9. So, another note I'd like you to write in your book is negative indices 0 and 1. So, a to the power of 1 is just equal to a. Anything to the power of 1 is the number itself, so we would give our answer without the power. So we just give it as a, not a to the power of 1. So, secondly, a to the power of 0 is equal to 1. Anything to the power of 0 is equal to 1, except for 0, which is undefined, as you cannot divide by 0. And if we have a negative indice, if we have a to the power of minus b, then that means that we've got the reciprocal 1 over a to the power of b. So negative indices gives you the reciprocal. When you multiply a number by its reciprocal, you get 1. Another name for the reciprocal is the multiplicative inverse. So these are three good indices to remember and rules. Right, so fractional indices. So using the index law for multiplication, what would we get for a to the power of a half multiplied by a to the power of a half? Well, a half plus a half is 1, so we'd end up with a to the power of 1, which is just equal to a. What about another example? If we had a to the third multiplied by a to the third times a to the third, well, it's a third plus a third plus a third, which would give me a to the power of 1. So therefore, fractional indices must give you the nth root. In other words, a to the power of half is the square root of a, and a to the power of a third is the cube root of a. So now we come to another law of indices, fractional indices. So write this in your book. A to the power of 1 over n is equal to the nth root of a. If you want to have a think about an extension, well, when we have fractional indices with the numerator that is not 1, the denominator in this example, so we've got a to the power of 3/5. So the denominator is 5, so that means it's going to be the 5th root. That's from our fractional index law. The numerator is 3, so that means that it's cubed. So we write it as the 5th root a in brackets all cubed. So that numerator means that it's cubed and the denominator gives us the root. Here is a summary of the index laws. What I'd like you to do is I'd like you to use those index laws and see if you can work out the value of these questions. Pause the video to work out your answers and justify your answers using the rules of indices. Okay, so I've given you some of the answers. Check your answers and check whether you use the correct law of indices. So, what I'd like you to do is spend about 5 to 10 minutes, working your way through simplifying these expressions as fully as possible. In the blue box, I've given you a challenge. Pause the video until you're ready to check your answers. Here are the answers, and check your answers, and it's good practice to practicing the law of indices. Okay, so using the law of indices, I'd like you to work out the following values. No, don't use your calculator, no calculators allowed. You're going to have to use your understanding for the fractional and negative indices and show you're working out. Spend about 5 to 10 minutes doing this and pause the video. Okay, here are the answers. Mark your answers and note if you made any mistakes, see if you can work out where you went wrong. If you get stuck on a particular type of question, go back at the beginning and read through and look again at your notes in your book about the law of indices. I'd like you to now work on this task, which is decide which group these expressions belongs to, and you need to convince me why. So either they're always true, or they're sometimes true, or they're never true. So pause the video and great. So here are the answers. So we've got always true, sometimes true, and never true. So mark your answers and have a read through, pause the video to check. You've got a 5-minute challenge. Can you do these all? I'd like you to work through and get some good practice. Pause the video until you're ready to check your answers. Okay, well done. Here are the answers. Check your answers and look back at the previous notes if you got anything wrong. And finally, to finish off this lesson, here are 6 questions. No calculators are allowed for practicing the law of indices. These are more like exam type questions. Pause the video until you're ready for the answers. Okay, here are the answers for the first 3 questions. We had find the value of something to a third and a minus indices. So the question 1 had fractional and negative indices. Question 2 had a negative fractional indice, and question 3 also had a combination. So start by turning the mixed numbers into improper fractions. Question 4 and 5 and 6 were also using fractional indices and using a bit of algebra too. So for question 6, you had to use algebra and express A in terms of C, simplifying your answer as much as possible. Well done for working really well in today's lesson. See you next time.